conspiracy theories are not magical mysteries beyond proof. Many can be checked with the same simple tools you use every day. Stick around, and first we'll show you how receipts, timestamps, photos, and a little common sense can expose a wild claim faster than a rumor spreads. Imagine someone says a famous building vanished overnight. Check news archives, traffic cameras, and eyewitness photos. That's detective work, not witchcraft. Sometimes a claim is precise and testable. Other times it's fuzzy and impossible to pin down. Knowing the difference is the skill first will teach you. No complicated labs, just practical steps, clear examples, and yes, a healthy dose of skepticism and humor to save you from chasing ghosts. Why this myth matters. Many claims pushed as mysteries are actually testable with ordinary tools like records, tests, and eyewitness accounts. So treating them as impossible to check wastes time and energy. Ordinary methods: looking at documents, asking experts, running simple tests, checking photos or video, and comparing statements from different people often reveal whether a claim holds up. For example, if someone insists a public building was secretly altered, blueprints, permit records, and contractor invoices can be checked, and those are not rocket science. In everyday life, people do this all the time. You call customer service, look at the receipt, check the security camera, or ask another witness. Short, practical steps. This myth matters because it shifts responsibility away from verification and toward rumor. When people assume something cannot be verified, they stop checking and start believing by default. That makes it easier for false claims to spread. In a family setting, that looks like taking sides in a rumor without asking for texts or receipts first. At city level, it looks like public outrage based on a distorted version of events. Both can lead to wrong decisions and unnecessary conflict. And yes, it could get expensive emotionally and financially. Also, saying conventional methods can't touch certain claims gives cover to people who want to avoid accountability. Audits, interviews, lab tests, and public records are basic ways societies hold people and institutions responsible. If a claim is labeled unverifiable, it blocks these checks and keeps problems hidden. A simple example: when coworkers whisper that someone fudged a report, a quick review of email drafts or version history can clear things up or show a problem that needs fixing. Ignoring those tools means trusting gossip over evidence. Not exactly efficient. Finally, the myth feeds distrust and polarization, which makes constructive action harder. People stop trusting experts and officials even when those people are using normal, reliable methods to investigate. That can lead to bad choices like rejecting medical advice or ignoring safety warnings. A light note: treating every hard-to-believe story as mysterious is like blaming the Wi-Fi for a dead laptop battery. Dramatic, but missing the real fix. Practical verification matters because it keeps conversations grounded, protects reputations, and helps solve real problems instead of creating new ones. Defining verification in plain terms. Verification is simply the process of checking whether a claim lines up with what actually happened or what really exists. It means taking a statement and looking for evidence that either supports or contradicts it, rather than accepting it because it sounds plausible or comes from someone you like. For example, if a friend tells you they returned a library book, you could verify that by checking the library account online or looking for the receipt. Short and useful. Start by making the claim specific. Vague statements are hard to check, so pin down who said what, where, and in what form. Next, look for direct evidence. Original documents, photos with metadata, video footage, receipts, or first-hand testimony from people who were actually there. When possible, try to reproduce the result yourself. If a recipe says it will rise in 20 minutes, bake it and see. If a device supposedly works a certain way, test it. Reproduction is a powerful form of verification because it shows the claim isn't a one-off fluke. It's like checking whether a light works not by peeking at it, but by flipping the switch. Consider the quality of the sources you use to check a claim. Primary sources, the original video, the official report, the lab measurement, are more reliable than secondhand summaries or reports that pass information along many times. Also pay attention to consistency. If several independent sources agree, but all trace back to the same original mistake, that's not real confirmation. A mechanic's opinion carries weight when diagnosing a strange car noise. An anonymous comment on a forum does not. Use multiple methods when you can. A photo can be checked for edits, a document for provenance, and a witness for consistency with other accounts. A little skepticism here is practical, not paranoid. Verification lowers uncertainty, but doesn't always give absolute certainty. Sometimes evidence is missing, damaged, or ambiguous, and you have to make a judgment call based on the balance of reliable information. Practical steps help. Ask for original files instead of screenshots. Seek independent experts. Try to reproduce findings yourself, and check whether evidence could be explained in simpler ways before jumping to complex conclusions. Think of verification as being a careful detective. Not because you're dramatic, but because you want fewer surprises. What qualifies as conventional methods? People rely on clear, repeatable steps to test a claim. Look for original documents, find independent witnesses, examine physical traces, and run tests others can copy. These are the practical things that count in everyday checks. They're the sorts of evidence courts, journalists, and scientists turn to because they can be shown to others and checked again. Documents and records are a big part. Receipts, emails, travel logs, meeting minutes, and official memos qualify because they leave a trail you can follow. For example, if someone says a meeting happened, an attendee list, calendar invite, or a recorded call can back that up. A single screenshot is weak. An original email with server headers is stronger. Short and simple, originals matter. Eyewitness testimony and multiple independent sources also fit. If 3 unrelated people report the same event from different angles, that builds confidence. In daily life, this is like asking 3 neighbors whether they saw a delivery arrive. If they all agree, the story is more believable. People make mistakes and memories can be fuzzy, so corroboration is the key word. Physical evidence and tests are straightforward. Things like fingerprints, DNA, surveillance footage, or material analysis are conventional because they can be examined in a lab and compared to known standards. If a claim involves a physical object, experts can analyze it and describe what it's made of. Labs run the tests. Other labs can repeat the tests. That repeatability is essential. Think of it like checking a cake recipe. If 3 bakers get the same result, the recipe is real. Reproducibility and peer review are also part of the toolbox. When a result can be reproduced by different people using the same methods, it moves from rumor toward verified fact. Scientists explain this simply. A finding that disappears when someone else tries the same thing is not reliable. In plain terms, it's like having 2 mechanics fix the same squeak the same way. You start to trust the diagnosis. Experts discussing and critiquing methods is not highbrow drama. It's how shaky claims are exposed. Digital forensics has become a regular method too. Metadata, server logs, original video files, and device records can show where a file came from and whether it was altered. A viral post with no source and blurry photos is like a fish story. The original raw footage plus camera data is the fishing rod. Short example, a doctored image may look convincing on social media, but the file's properties and source server logs often tell a different story. Chain of custody and openness are practical qualifiers. Evidence that changed hands anonymously, was tampered with, or that can't be inspected by independent experts has low value in conventional verification. If someone claims proof but refuses to share it for checking, skepticism is reasonable. It's comparable to being offered a special jam but not allowed to taste it or see the jar. Suspicious and a little rude. Limitations exist and should be acknowledged. Some events leave little trace. Witnesses can be unreliable, and secretive setups are harder to verify with these methods. Still, the bar for something to count as verified is concrete. Traceable sources, repeatable tests, independent confirmation, and transparent methods. That's the checklist people use when they want to move a claim out of rumor and into evidence. Science, falsifiability, and testability. Science cares about whether a claim can be checked against the world, not about how dramatic the claim sounds. Falsifiability is a simple idea. A statement must allow for something that would show it to be wrong. If a claim never allows for any possible evidence to count against it, then it can't be tested in the way science tests ideas. That doesn't mean the claim is true or false automatically. It just means science can't weigh it. Short claims that point to observable things are easier to test. Long, woolly claims that change whenever someone points out a problem are not. Testability is about concrete checks. A testable claim points to things you can observe, measure, or repeat. For example, if someone says a certain food in the office always makes people sick, you can look for patterns, check ingredients, and compare who eats it and who doesn't. If a claim is that a hidden group controls every government decision but refuses to provide any specifics, that's not testable. It's like a riddle with no answer. Everyday life is full of testable and untestable statements. A friend saying they saw a rare bird in the park can be checked by going there, looking for evidence, or asking others. A claim that every time you wear red socks you lose your keys is testable too. Track socks and keys for a while. It might be silly, but at least you can collect data. Practical steps make testing less mystical. First, define the claim clearly. Avoid vague words like always and everyone. Next, identify what you would expect to see if the claim were true and what you'd expect if it were false. Then pick ways to observe those signs: independent sources, physical samples, or repeatable actions. If someone asserts that a product contains a hidden ingredient, you can check the ingredient list, consult independent labs, or compare batches. If evidence appears, ask whether it could be explained by something ordinary before leaping to grand conclusions. And if a claim keeps shifting whenever evidence appears, that's a red flag that it's been made deliberately hard to test. Psychology and social behavior explain why unfalsifiable claims persist even when testable alternatives exist. People tend to favor stories that fit their fears or hopes, and some claims are crafted to dodge scrutiny by being all-purpose. It's useful to remember that a lack of testability is not proof of a cover-up. It's a sign that the discussion has moved out of the realm where evidence matters. For a quick rule of thumb, demand specific predictions, look for independent checks, and prefer claims that expose themselves to being proven wrong. That approach is less glamorous than conspiracy drama, but it's also the fastest way to find out what's likely true, and to avoid chasing invisible strings like a cat chasing a laser pointer. Evidence hierarchies explain simply. Not all evidence carries the same weight when you're trying to figure out what's true. Some kinds of proof are built to avoid mistakes and bias, while others are just single stories or gut feelings. Think of evidence like a ladder. The higher the rung, the firmer the footing, and the less likely you are to fall for a misleading wobble. At the top are things that combine results from many independent tests, because repetition across different settings is powerful. When many separate studies show the same result, and someone has carefully pulled them together, that gives a clear signal. Below that are studies that randomly assign people to different treatments. That randomness helps make sure the groups are similar, so any difference is likely due to the treatment and not something else. In everyday terms, it's the difference between a controlled taste test and a friend saying, "This soda cured my headache." Further down are observations where people watch what happens without assigning anything. These can spot patterns but can't always prove cause and effect. Near the bottom sit single cases, glowing testimonials, and expert opinions that aren't backed by broader evidence. A single moving story can tug at your heartstrings, but it doesn't by itself prove a general rule. Concrete examples make this easy to see. If a friend swears a certain app doubled their productivity, that's a single anecdote, useful to consider but not decisive. A randomized test where two similar groups of users are tracked and one group uses the app while the other doesn't gives much stronger information. And if several independent teams run similar tests and all find the same improvement, that's even more convincing. Another example, online reviews can be helpful, but hundreds of balanced reviews from many buyers beat one viral video. Short sentence. Fact-checking becomes simpler when you know which types of evidence matter most. When you want to verify a claim, look for repetition, independence, and transparency. Independent means the people testing something aren't the same folks who profit if it succeeds. Repetition means different teams in different places get similar results. Transparency means methods and data are shared so others can check. Correlation versus causation matters here. Two things happening together doesn't mean one caused the other. A quick life example is noticing that taller people tend to buy larger shoes. Height and shoe size go together, but height doesn't make shoes bigger. Practical steps help you apply this latter in daily life. Ask where the evidence comes from: a single post, many tests, or an independent roundup. Check whether results were repeated by others. Be skeptical of neat stories with no follow-up. Look for signs of bias, like tests paid for by people who benefit from a particular outcome. And keep in mind that even the best evidence has limits. Nothing is ever absolutely certain, but some kinds of proof get you much closer to the truth. A little common sense and a tiny bit of healthy suspicion go a long way, and they won't cost you anything at the checkout. Pattern recognition versus pattern seeking. Our brains are wired to pick out order from noise. It's a survival trick that helped ancestors spot a predator in the bushes and helps you notice the pattern of red lights on your commute. At its best, this quick, automatic pattern recognition saves time and keeps you alive. It also explains why you can instantly recognize a friend's face in a crowded room or spot a familiar tune hidden in a remix. Fast and often reliable. But there's a flip side. Pattern seeking is the deliberate hunt for connections, even when they might not be there. This is when you squint at random facts until they line up into a story you like. It feels clever. It also invites mistakes. People who collect coincidences and string them together often forget to ask how likely those coincidences would be by chance, or how many other non-coincidences they ignored. Short version: noticing is different from hunting. Everyday examples make the difference obvious. Seeing a face in the clouds is pattern recognition. The sky happens to form shapes that your brain labels as a face. Scouring dozens of weather photos to prove the clouds are signaling a secret message is pattern seeking. Another case: you call a friend, and their phone rings right as you think of them. Recognition notes the coincidence. Pattern seeking builds a theory that your thoughts are being transmitted through an unexplained channel. One is a single observation. The other adds a narrative and ignores simpler explanations. People also fall into pattern seeking because it feels satisfying to find meaning. A stock goes up after you complain about it, so you declare yourself a market whisperer. Quick claim: the more careful approach asks whether the move was part of normal fluctuation, whether other factors drove it, and how often your prediction actually happened versus times it didn't. A practical trick: ask what would count as disproof. If no conceivable evidence would change your mind, you are likely pattern seeking, not reasoning. Try a simple test on your own thinking. Count how many times something similar happened, but you didn't notice or mention it. This exposes selection bias, the habit of remembering hits and forgetting misses. Also compare against a baseline. How often would that event happen randomly? If a coin lands heads 5 times in a row, that feels special, but 5 heads in a row can and does occur by chance. Lean on basic comparisons. They calm the imagination. Another useful habit is to look for independent confirmation. If only sources that already agree with you see the pattern, that's a red flag. If multiple, unrelated observers report the same unusual pattern under controlled conditions, then pattern recognition is being validated. Otherwise, you may be collecting echoes from the same room. And yes, humor helps. Just because your toaster burned one bagel after you grumbled about a kitchen plot does not mean household appliances are in cahoots. That kind of thinking is pattern seeking dressed up for a costume party. In short, pattern recognition is a fast, often helpful faculty for spotting order. Pattern seeking is an active, sometimes biased search that fills gaps with meaning. Keep a skeptical checklist. Consider chance, seek independent observers, ask what would disprove your idea, and remember how many non-events you passed over. Do that, and your knack for spotting real patterns will work for you instead of against you. Reproducibility and independent replication. Tests that produce the same outcome when repeated by different people are treated as stronger evidence across many fields. courts, newsrooms, and labs all look for that kind of consistency. Reproducibility simply means someone else can follow the same steps and get the same result, while independent replication means a separate person or team, using their own equipment or methods, reaches the same conclusion. Think of it like a recipe. If 3 neighbors follow the same recipe and each bakes a chocolate cake that tastes like chocolate, the recipe probably works. If only the original baker gets a cake and everyone else gets a sad pancake, something else is going on. Practical examples help make this real. If a leaked photo is claimed to show a secret meeting, independent checks can compare camera metadata, lighting and shadow angles, and other public footage from nearby cameras. If those independent checks line up, the photo gains credibility. Likewise, a claimed chemical test result can be sent to a neutral lab for confirmation. Labs run the same basic steps, and if the claim is solid, they will find the same chemicals. A simple everyday example. If several coworkers complain about food poisoning after the same takeout, local health inspectors can test leftover food and cultures. When multiple tests find the same bacteria, that independent replication points to the food as the likely cause. When other people replicate a finding using different tools or data sets, it reduces the chance that the original result was a fluke, an error, or bias by a single person's perspective. Varied replication methods are powerful. Digital forensics teams might validate a document's metadata. Journalists can contact independent witnesses, and open-source analysts can analyze satellite images or signal data. Even amateur checks matter. Community volunteers can cross-check timestamps, map locations, or verify audio by comparing it to known voices, and multiple independent confirmations make a claim far more robust. There are limits, of course. Sometimes evidence has been destroyed or access is blocked, so replication can be hard. Still, asking for clear steps, original files, and independent tests is a practical way to move from suspicion to verification. If you want to vet a claim, request the raw evidence. Look for independent analyses and favor results that others can and do reproduce. It's detective work with a method and no lab coat required. Forensic techniques and document analysis. Physical pieces of paper often tell their own story through tiny details. The type of paper fibers, a watermark tucked into the sheet, and the way ink spreads into the fibers. Experts use simple tools like magnifying lenses and solutes to separate ink colors, so they can see whether 2 pens made the same mark. That process, called chromatography, is basically a chemistry trick that pulls apart the dyes and ink so you can compare them side by side. For ordinary folks, a quick check is revealing too. An allegedly centuries-old letter printed on laser copy paper is a big red flag. Forensic examiners look for those red flags without needing a crystal ball. Handwriting and signatures are another readable clue. Analysts compare the rhythm and shape of letters, the pressure on downstrokes, and the way a person dots their I's or crosses their T's. Small things count. A shaky line where a forger tried to slow down, or a letter that never appears in a genuine sample, can betray a fake. There are also ways to see what was written beneath an erase line by checking indentations left on the page, like reading the ghost of earlier notes. So if someone claims a secret note proves a massive plot, a close look at the handwriting and the underlying impressions often tells whether it's real or a hurried forgery. Digital documents bring different but equally testable clues. Files carry metadata. That is, hidden facts about the file, such as the program used to create it, the author tag, and modification times. And even pictures have EXIF data listing camera details. Email headers show the route a message took and can point to the originating server, which helps verify who sent what. Screenshots and PDFs sometimes hide inconsistencies. Fonts that don't exist on the supposed author's system, mismatched margins, or compression artifacts that give away edits. Printers add their own signatures too. Some color printers leave tiny dot patterns that can be traced back to a specific machine. None of these are magic proofs alone, but together they build a strong picture. There are limits and common sense steps to keep in mind. Experts must follow a clear chain of custody so a document's history is recorded and admissible in formal settings. Without that, even the best analysis can lose credibility. For people assessing claims outside the lab, Simple checks help. Ask for original files, look for inconsistent spelling or logos, check headers on forwarded emails, and compare alleged originals to known document from the same source. In many cases, conventional techniques pick up the breadcrumbs left by sloppy falsifiers, because even the cleverest hoaxer rarely remembers to clean up every microscopic clue. A hint of humor helps here. Forgers can be creative, but they're not invisible, and even small mistakes stand out like coffee stains on a white shirt. Digital footprints, metadata, and logs. Most photos and files carry hidden facts inside them that people rarely notice. These hidden facts are called metadata. Think of them as sticky notes attached to a file that say when and where it was made, which device made it, and sometimes even what settings the device used. For example, a smartphone photo often contains GPS coordinates and a timestamp inside its EXIF metadata, and a music file can include the name of the program that created it. This kind of information is easy to view with simple tools on a phone or computer, and it gives investigators and ordinary people alike a straightforward way to check details without needing anything mystical. In daily life, there are lots of ordinary sources of metadata and logs that back up or contradict statements. Email headers record the route an email took and include IP addresses of the sending servers. Web browsers keep a history and cache that show what pages were visited. Smartphones keep location histories and app logs. Bank and card systems create transaction logs. Building security systems record badge swipes and CCTV timestamps. A grocery receipt with the time printed on it or a commuter card check-in record do the same job in the physical world as a server log does online. These records often match up, so checking several at once can be very convincing. Forensic checks are simple and practical, not magic. Compare the timestamp on a photo to the timestamp in a device's file system, and then match those to a phone cell tower or Wi-Fi connection log. Look at an email's header to find the IP address where it originated and then check whether that IP belongs to the claimed location. If a social post says someone was downtown, but the phone's Wi-Fi history shows it was connected to a home router in another neighborhood, that discrepancy is a red flag. People sometimes try to strip or change metadata, but those edits often leave their own clues, like inconsistent timestamps, missing camera model information, or file fingerprints that don't match the claimed source. Practical examples help make this concrete. If a friend shares a photo from a festival and the EXIF data shows the phone model is different for what they normally use, ask why. If a colleague insists they were at their desk at 3 p.m., the server's login logs and the building's door logs will usually say otherwise. Even simple cross-checks work. A bank transaction timestamp plus a card's terminal location can place someone at a store, while a matching CCTV clip can confirm it. These are everyday traces that most people leave behind, like a breadcrumb trail of electronic evidence. Keep in mind that metadata and logs are tools, and like any tool, they can be misread if used carelessly. Correlating multiple independent sources reduces mistakes. Don't rely on a single file's metadata as proof, but use it alongside network logs, receipts, and camera footage. Also, privacy settings and data retention policies vary. Some logs are kept for a long time, others are deleted soon after. Still, in many cases, the digital footprint is durable enough to provide clear, real-world clues. And yes, despite what some might hope, there's no secret undo button that wipes away all traces without leaving something odd behind. Even digital ghosts leave footprints. Eyewitness accounts and corroboration. People often trust what they see with their own eyes, but memory and perception are not foolproof. Bright light, clear distance, and a calm mind help accuracy, while darkness, rain, short glimpses, and panic make mistakes much more likely. For example, someone who glances once at a license plate during a screeching stop is less reliable than a person who calmly reads the plate while standing nearby. Simple things like angle of view and how long you look matter a lot. Independent corroboration turns a lone recollection into something more convincing. That can mean another person who saw the same thing without talking to the first witness, a photo or video, a receipt, or a phone location log. If two people separately tell the same story, and their accounts match in details that aren't obvious, that's stronger than two people reciting the same story after discussing it over coffee. Shared conversation often spreads the same wording and details, which is called suggestion. In plain terms, people can unintentionally coach each other's memories. Confidence doesn't equal correctness. Someone can be utterly sure about a detail and still be wrong. Memory can feel vivid, yet be faulty because the brain fills gaps with likely or comfortable details. Think of your memory like a badly captioned photo. It looks crisp, but the caption can be off. Misidentifications in crowded places are common. A person might confidently point to the wrong face in a lineup simply because stress narrows attention to a few features or because they saw a similar jacket earlier. Practical checks help sort reliable eyewitness claims from shaky ones. Ask about lighting, distance, how long the witness observed the event, whether they were distracted, and whether they spoke to other witnesses before recounting it. Look for objective records, video footage, timestamps on messages or posts, transaction receipts, or phone location traces. Be cautious when multiple witnesses all heard the same story secondhand. Independent, unprompted agreement is the gold standard. And remember, corroboration can be misleading too if everyone relied on the same flawed source, like a viral clip or a single rumor that spread fast. Putting it together, eyewitness reports are useful but fallible. When combined with independent evidence and careful questions about what conditions were like, they can support a claim solidly. When they stand alone, they should be treated as one piece of the puzzle, not the whole picture. Statistics, anomalies, and red flags. Statistical clues are often the first practical tool for sorting strange claims from genuine problems. Look at how many observations there are and where they came from. A handful of dramatic stories does not equal a pattern. Small samples can create big illusions. A few loud examples can feel like proof when they're just noise. Think of it like noticing a few people at a party who all wear the same hat. Interesting, but not evidence that everyone in the city owns that hat. Anomalies are simply things that deviate from what you would normally expect. They can be innocent, random blips that happen all the time, or meaningful, pointing to something worth investigating. To tell which is which, compare the anomaly to a reasonable baseline. What usually happens in similar situations? If your neighbor finds 3 rare birds in his yard, that's an anomaly. If several neighbors in different parts of town report the same rare birds, that's a stronger signal. Context matters. Also consider independence. If all reports come from the same closed group or the same person repeating the story, that weakens the case. There are clear red flags to watch for when a claim leans on statistical sounding language but lacks substance. Cherry picking is common. Choosing only the examples that fit the story while ignoring everything that doesn't. Graphs with no axes or missing units are another giveaway. If a chart looks too tidy, treat it like a cake with no crumbs. Reliance on a single source, anonymous evidence that cannot be checked, or refusal to share the raw data are all signs to be cautious. Another tip, check whether the claim requires improbable coordination across independent actors. If so, ask how that coordination could realistically occur. Practical checks are simple and effective. Ask for the raw counts, not just percentages, and look for repetition. Can independent parties replicate the finding? Examine the sampling method. Who was asked, and how were they chosen? Watch for shifting definitions, where the goalposts move once a claim is challenged. In everyday life, that's like someone changing the rules of a game mid-play. Finally, apply basic plausibility. Extraordinary claims need stronger, independently verifiable evidence. A little skepticism and some straightforward statistical thinking will save time and prevent you from mistaking random oddities for hidden plots. And that's worth more than a conspiracy-shaped hat. Expert consensus and peer review. Across fields, claims are weighed not by one loud voice, but by many trained eyes checking the same evidence. Peer review is simply the routine where other experts read a research paper before it appears in a scientific journal, pointing out errors, gaps, or sloppy thinking. It's like asking several mechanics to inspect a car before you buy it. Expert consensus happens when those independent checks and follow-up studies start pointing in the same direction. Not because people agreed to agree, but because multiple lines of evidence led them there. In plain terms, if dozens of well-trained people using different methods reach similar conclusions, that outcome deserves serious attention. A familiar, everyday example makes this less abstract. A doctor giving a diagnosis will often suggest a second opinion or run tests. When several doctors independently see the same signs and test results, the diagnosis becomes more reliable. Similarly, product testing organizations run the same toaster or phone through standardized checks and publish their results, so consumers don't rely on a single review. Those are practical versions of peer review and consensus. Independent checks, repeated observations, and public reporting. That system isn't flawless, and a bit of healthy skepticism helps. Peer review can miss deliberate fraud or clever mistakes, and early studies sometimes show flashy results that later research fails to reproduce. Still, the difference between a claim that sits in a single blog post and a claim supported by articles in respected journals plus statements from professional groups is huge. Think of it as comparing a rumor at a party to a conclusion that survived being grilled by many experts who aren't paid to be your friend. When evaluating a suspicious claim, look for the footprints of that process. Check whether multiple independent teams have tested the idea, whether their results are available in reputable outlets, and whether recognized professional bodies have issued assessments. If those signs are absent, treat the claim accordingly. And for the record, consensus is not a secret handshake. It's the slow, noisy, sometimes boring work of people checking each other's work until the story holds up. And that is usually the strongest practical way we have to separate shaky conjecture from reliable knowledge. Open source intelligence, OSINT, basics. Collecting information that is already out in the open is the core idea behind OSINT. And it simply means using public sources, like news sites, social media, maps, and public records, to answer a question or check a claim. You might use a search engine to find a company press release, scan a public Facebook or 10th post for context, or pull a satellite image from a map service to see if a field really exists where someone says it does. These are everyday techniques that turn ordinary web browsing into structured investigation. Think of it as careful, patient Googling with a notebook and a tiny magnifying glass. Figuratively speaking, of course. Tools and tricks matter, but they're not magic. Reverse image search can show where a photo first appeared online and whether it's been reused elsewhere. Checking a picture's EXIF metadata can sometimes reveal what device took the photo or even GPS coordinates, though many platforms strip that info before posting. Search operators like cite and file type help narrow results. Use cite.gov to find official documents, for example. The Wayback Machine, a public web archive, lets you see older versions of a web page if someone deleted or changed content. A casual example: before forwarding a dramatic photo, a quick reverse image search might reveal it's from a travel blog posted years earlier, not a breaking news event. Verification is the habit that separates useful OSINT from wild guessing. Cross-checking is the simple rule. If 3 independent sources say the same thing, and at least one is primary or official, that claim becomes more credible. Look at who posted the information, how old the account is, and whether timestamps, locations, and content match other evidence. For example, if a viral video claims to show damage in a city, compare the skyline and road signs with map images. Check local news outlets and run a reverse image or frame search to see if the footage appeared before the claimed event. Little inconsistencies, like mismatched weather in photos or shadows pointing the wrong way, are the tiny clues that often expose mistakes or fakes. Ethics and limits should guide every search. Only gather information that is publicly available and avoid trying to hack or pry into private accounts. Stay on the legal side, keeps you out of trouble, and your findings credible. Always record where you found each piece of evidence: a URL, a screenshot with a timestamp, or the search terms you used, so others can follow your steps. Practical examples help. A community group can use free satellite imagery to monitor a local construction site. A journalist can use public company filings to confirm a funding claim. And a person can verify whether an alarming social media claim came from a reputable source before resharing. And yes, don't be the person who spreads a rumor because the meme looked convincing. Everyone's inbox is already full of that kind of chaos. Historical conspiracies that were proven. The Watergate scandal is one of the clearest cases where a supposed crazy story turned out to be true. A break-in at a political office, a long cover-up, and then recorded conversations that proved leaders had lied and tried to hide the truth. The tapes left little room for doubt. Ordinary people can relate. If you deny eating the last slice of cake, but there's footage of you with frosting on your face, the case is closed. Investigative reporting, court records, and the release of direct evidence all combine to verify what started as rumor. Another proven conspiracy that changed how we think about ethics involved medical researchers who watched harm happen instead of stopping it. Public health officials studied a group of men without telling them the full story and without giving proper treatment, even when effective medicine existed. When that information was exposed, it led to new rules that forced doctors and researchers to get clear consent from people and to protect them. The kind of basic respect everyone expects from their doctor. Think of it like a repair shop watching a car fall apart to learn more about rust without ever offering to fix it. Once people learned what happened, they demanded better safeguards. The CIA's experiments into behavior control also moved from conspiracy talk to documented fact. Files later showed that intelligence agencies tested drugs and techniques on people, sometimes without their consent, trying to figure out ways to manipulate minds. Congressional hearings and declassified papers pulled the story out into the open, and now it reads like a cautionary tale about secrecy and ethics. You could joke that this isn't the kind of new perspective you want at a dinner party, but the real lesson is serious. Oversight matters. Domestic intelligence programs that targeted political activists were likewise exposed and verified. Agencies planted agents, spread false stories, and tried to disrupt social movements instead of simply monitoring threats lawfully. When internal memos and documents were made public, the scale of the operations became undeniable and public outrage followed. It's a bit like a nosy neighbor who doesn't just watch but starts cutting people off from each other. Except far worse because it was done by institutions with power. Big industry cover-ups have been proven too. Companies sometimes hid evidence that their products were harmful while they carried on selling them. Internal documents, legal cases, and settlements showed that executives knew more than they admitted. The result was not only fines and public anger, but also tighter rules and more pressure for transparency. Imagine buying a toaster that overheats and the company privately knowing about it, but continuing to ship boxes. Customers would be furious, and rightfully so. There are also proven cases where governments considered or planned deceptive acts to gain public support for military moves, but were stopped before they were carried out. Declassified plans show that officials sometimes discussed staging incidents to sway opinion. The fact these documents exist and were produced through official channels proves that such thinking happened. Thankfully, not all ideas make it past the table. In everyday life, the parallel is petty, plotting a fake surprise party by hiding the cake. But at the level of statecraft, it's a scary reminder of why checks and records matter. Taken together, these examples show how conventional methods, journalism, court cases, congressional hearings, declassified papers, and whistleblowers can turn whispers into proven facts. Real evidence often comes down to documents, recordings, and sworn testimony. So while some conspiracies are wild fiction, many harmful schemes have been uncovered using ordinary tools. That's comforting and worrying at the same time. Debunked theories that fooled people. Many widely told claims that sounded convincing at first were later shown wrong by ordinary checks like looking closely, measuring properly, and repeating the test. Scientists and investigators use basic tools, careful observation, simple experiments, and records that others can check to sort fact from fancy. People get fooled when a story fits what they already fear or when a surface detail seems to prove something. One clear example is the line of white streaks behind high-flying jets. Those streaks are ordinary contrails, just hot, moist air from the engines hitting very cold air and turning into tiny ice crystals. On certain mornings, they spread and stick around, which makes them look deliberate. A quick, real-life test is enough. Those trails start and stop with normal air traffic patterns and change, depending on humidity and temperature, not on secret spray schedules. So a little weather knowledge and a look at aviation records do the debunking. Claims that astronauts never walked on the moon were also checked with regular methods and found wanting. Independent observers, including amateurs and foreign tracking stations, recorded spacecraft signals and trajectories that match the missions. Rocks brought back have chemical fingerprints different from ordinary Earth stones and match what you'd expect from a body that formed in a different place. Scientists study those samples like detectives study clues. There are also pieces of hardware left behind, such as reflective devices that still bounce lasers sent from Earth. Point a laser at them, and you get a return signal. Point one at a prop in a studio, and you do not. Simple, repeatable tests like this settled the question for people who care to look. The idea that vaccines cause autism fooled many because the timing often looks suspicious. Vaccinations happen in early childhood, and that is when developmental signs also appear. But careful comparisons between vaccinated and unvaccinated groups, done by different teams around the world and repeated many times, turn up no link. Think of it like testing whether a particular brand of shoes makes people trip more. You compare lots of walkers wearing different shoes under the same conditions. If the tripping rate is the same across groups, the shoe isn't to blame. An early study that suggested a link was later shown to have serious problems and was withdrawn, which is how science corrects itself. That doesn't erase parental worry, but it does point to why large, repeated checks matter. Other widely believed ideas, like the Earth being flat, collapse under plane observation and simple experiments. Sail a ship away and its hull disappears before its mast does. Fly south, and you see different constellations. Modern satellites photograph the globe from space, and airline routes make practical sense only on a round planet. Even hoaxes that once fooled experts, such as famous fossil fakes, were exposed by routine lab work. Chemical tests, microscope checks, and toolmark analysis showed artificial alterations. In everyday terms, it's the difference between a convincing antique that actually smells old and a fake that peels under a fingernail. These cases all share a lesson: ordinary methods, looking carefully, measuring, and asking others to repeat the test, often reveal the truth. A pinch of curiosity, a bit of patience, and a tiny dose of skepticism go a long way. And yes, sometimes the conspiracy theory just needed better sunglasses. Legal standards, civil versus criminal proof. Courts treat criminal and civil cases very differently when it comes to how strongly facts must be proved. In criminal trials, the government must convince a jury that the defendant committed the offense to a very high level of certainty. While in civil cases, the person bringing the lawsuit only needs to tip the balance of probability in their favor. A third, middle level called clear and convincing, sits between them and appears in certain civil claims that are more serious than ordinary disputes. Beyond a reasonable doubt sounds dramatic, and it is on purpose. It does not mean absolute certainty, which is rarely possible, but it does mean jurors should be firmly convinced of guilt after considering all the evidence. Think of a criminal case where someone's liberty is at stake. The standard is intentionally high because the consequences can be severe, like imprisonment. Short sentence. Prosecutors, therefore, must present persuasive witnesses, reliable documents, and clear links between those pieces of evidence to meet that burden. In civil cases, the phrase normally used is preponderance of the evidence, which is much easier to reach. If the evidence makes one version of events more likely than not, in other words, better than a 50-50 chance, the plaintiff wins. A routine example is a car accident lawsuit. If the injured driver shows that it's more likely the other driver ran a red light, the injured driver can recover money from medical bills. Less pressure. Many everyday disputes, from contract fights to slip and fall claims, are decided this way. Some civil matters require clear and convincing proof, a middle ground that asks for a high probability, but not the near certainty of criminal law. This standard often applies when the outcome could severely affect someone's rights or reputation, such as certain fraud claims or challenges to a will. The court wants stronger proof than a simple preponderance before making such a serious decision. Burdens shift too. The person who brings the claim normally bears the burden of persuasion, while the defendant may have the burden of producing evidence for certain defenses. In practice, the higher the standard, the more and better evidence you need. Think of it as turning up the microscope on the facts. The closer you look, the clearer the picture must be. A touch of legal humor. If evidence were coffee, preponderance would be a black cup, clear and convincing in espresso, and beyond a reasonable doubt, a triple shot that will wake up any skeptical juror. Bayesian thinking for real-world claims. People change their minds when new facts arrive, and that process can be done more carefully than first heard it from someone. Think of beliefs as guesses you carry around. Some guesses are strong because they match what usually happens, and others are weak because they would be surprising if true. Bayesian thinking is just a tidy way to balance what you already think, the prior, with how well new evidence fits each possibility. In plain language, start with how plausible a claim was before the new evidence, then ask how likely the evidence would be if the claim were true versus if it were false, and update your belief accordingly. A simple, everyday case makes this clear. If you drop your phone in the house, you first assume it's under a couch cushion, not that it teleported. That assumption is your prior. Now suppose you hear a ringtone behind the fridge. That is the new evidence. If a ringtone behind the fridge would be almost certain if the phone were there, but unlikely if it wasn't, you raise the chance the phone is indeed behind the fridge. If later you find a ringtone app recently installed by your kid, you lower your confidence again. Short sentence for emphasis. Evidence can cut both ways. Medical tests illustrate the same idea without any math jargon. A test can be good and still give false alarms, especially when the condition is rare. There are many more healthy people than sick ones, so even a few false positives among many healthy people can outnumber the true positives. So the sensible move is not to panic at a single positive result, but to combine the test result with how likely the illness was to begin with, then seek confirmation. In practice, that means asking for a follow-up test, a second opinion, or stronger evidence before changing your life plans. When claims are extraordinary, like secret plots that explain lots of unrelated things, treat the prior as low and demand stronger evidence. Ask what you would expect to see if the claim were true and whether those observations are actually present. For example, if a group secretly controlled a big public system, would there be no leaks, no paperwork, and no whistleblowers? That's unlikely. Check independent sources and look for predictions the claim makes that you can test. A handy rule: the stranger the claim, the better the proof needed. A dash of skepticism helps. Too much faith without evidence is just wishful thinking. Practical steps make this usable. First, state how plausible the claim was before the new information. Second, consider how much more likely the observed evidence would be if the claim were true than if it were false. Third, look for independent confirmation and alternative explanations. Fourth, update your belief slowly and be willing to change it again as new evidence arrives. Think of it as cooking: taste, adjust, and taste again. It's not mystical math. It's simply weighing how much the new facts change what you already thought, and that habit keeps you honest and less likely to be fooled. Secrecy, plausibility, and hidden mechanisms. Secrecy is a normal tool used by companies, governments, and even families, and it does not automatically mean something sinister is happening. Companies keep trade secrets, like the famous Coca-Cola recipe, to protect their business. People sign non-disclosure agreements when they work on a film, a patent, or a new product. That paperwork is often about money and competition, not world domination. Sealed medical records and private board meetings are routine too. And storing information behind a password or in a locked drawer is more about privacy and legal duty than evidence of a vast hidden plot. Not everything hidden is nefarious. Sometimes it's just paperwork and bureaucracy. Plausibility matters when judging a claim that something secret is being covered up. A story that requires hundreds of people, millions of dollars, and perfect silence for years is much harder to believe than one that could be explained by a small error or miscommunication. Consider the difference between ordinary airplane condensation trails, which form when hot, moist exhaust meets cold high-altitude air, and the claim that those lines are part of a global spraying program. The latter needs an enormous, coordinated mechanism and many quiet participants to be true, while the former is explained by straightforward physics. Think about coordination problems. Getting a dozen coworkers to hide a mistake for a week is hard enough. Keeping hundreds quiet forever is exponentially harder. Short and simple. The more moving parts a secret needs, the less likely it is to hold. Hidden mechanisms are the actual processes that would have to exist for a claim to be true, and they often leave practical traces. Paper trails, email headers, purchase orders, internal memos, maintenance logs, and bank transfers are the kinds of things that build any large operation. They also create opportunities for exposure through leaks, whistleblowers, audits, or investigative reporting. Many alleged secret systems collapse under scrutiny because those practical traces don't add up. For instance, if a product were being secretly altered on an assembly line, invoices and shipping manifests would probably show unusual orders. If no such anomalies appear, the secret mechanism is less plausible. That said, small-scale secrecy, like someone hiding a side hustle from their spouse, can be easier to maintain simply because fewer records and fewer people are involved. Classic human problem. Coordinating a conspiracy is like herding caffeinated squirrels. Practical checks help move a claim from rumor to evidence by testing whether the proposed hidden mechanisms actually work in the real world. Independent lab tests, audits, freedom of information requests, data checks, and basic fact-finding by journalists or analysts often reveal whether an alleged secret operation has substance. If a device is supposedly transmitting private data, for example, network traffic and routine testing by third parties can often spot unusual behavior. If a public program is claimed to be a cover for something else, budget lines and procurement records are logical places to look for confirmation. Small mistakes frequently topple big stories. In short, secrecy can delay discovery, but rarely prevents it forever. And plausibility coupled with a look for real, physical or documentary mechanisms is the sensible way to separate dramatic rumors from claims worth investigating. Whistleblowers, verification challenges. A whistleblower's report often arrives as a jumble of fragments. A photo, a forwarded email, a shaky voice memo, maybe a spreadsheet with odd entries. These items are useful, but useful does not equal incontrovertible. Documents can be altered, photos cropped, and short clips stripped of context. A receptionist who forwards a picture of a cracked bridge beam is helpful, yet the same image could have been taken after an unrelated incident or even staged. Context matters. Verification needs to untangle what is real from what is incomplete or misleading. Technical clues are a first line of defense, and they are straightforward to explain. Digital files carry traces, metadata in a photo or the header in an email, that say when and where a file was made or routed. Server logs and access records can show who logged into a system and when. But those clues are not foolproof. Metadata can be edited, device clocks can be wrong, and cloud backups sometimes rewrite timestamps when they sync. An audio clip might have splices. A video can be doctored so smoothly that only a trained eye notices. So while these digital fingerprints are valuable, they require careful handling and a bit of technical know-how to interpret correctly. Think of it like checking the label on a can at the grocery store. It helps, but sometimes you still have to sniff. Human sources and paper records remain essential because they add context that bytes alone cannot deliver. Colleagues who saw the event, Internal logs that record routine tasks, CCTV footage, delivery receipts, and maintenance schedules are the kinds of things investigators look for to corroborate a claim. For example, a hospital staffer alleging medication mishandling might point to discrepancies between the pharmacy's inventory reports and actual counts on the floor. Cross-checking those records, looking at electronic dispensing logs, and interviewing pharmacy techs can build a clearer picture. The catch is that checking humans often risks exposing the whistleblower, so verifiers balance thoroughness with protection. Journalists and investigators use techniques like redacting identifying details and using secure Dropbox to reduce that danger. There are hard limits to what verification can achieve, especially when actors are sophisticated or records are deliberately erased. Some forgeries are convincing enough to fool casual inspection, and sometimes the most telling evidence has been deleted or never recorded. In those cases, pattern recognition becomes important. Repeated anomalies, consistent testimony from unrelated insiders, and discrepancies across independent systems can be as persuasive as a single smoking document. Still, these are judgments of probability rather than absolute proof. It's like putting together a jigsaw with a few missing pieces. You might see the picture, but you can rarely claim every tile is original. Practical steps help both whistleblowers and those who verify their claims. Keep originals when possible, preserve timestamps, capture multiple types of evidence, a photo plus a dated email plus a witness, and avoid altering files before handing them over. People doing the checking should document the chain of custody, consult IT or forensic specialists for technical artifacts, and seek independent sources to confirm facts. Use secure methods to communicate and consider neutral third-party auditors when stakes are high. Verification is often slow and fiddly, and sometimes it feels like detective work after too much coffee. But careful, layered checking can turn a lone allegation into a credible claim. Disinformation networks and intentional obfuscation. Many bad actors build webs of fake accounts, coordinated posts, and recycled content to make a simple lie look like a crowdsourced truth. They copy pieces of real reporting, change one detail, and then push the altered item through dozens of accounts so it appears repeatedly in searches and feeds. This technique relies on repetition and familiarity. When you see the same claim everywhere, your brain treats it as more likely to be true. Social media platforms can amplify that repetition automatically because their algorithms reward engaging patterns more than nuanced accuracy. A common trick is to use automated accounts, known as bots, to like and share material, so it trends quickly. Some accounts are controlled by people pretending to be regular users, which is why you might encounter a flood of similar comments praising a product or political claim. Another frequent move is information laundering. False or fringe claims first appear on small sites or private chats, then get quoted by slightly larger pages, and eventually reach mainstream outlets as if they had independent backing. The original source gets buried in this chain, making verification much harder. Obfuscation also looks like deliberate noise and confusion. Perpetrators will drop contradictory versions of a story, mix in true facts with false ones, or overload search results with irrelevant content so that straightforward checking is time-consuming. They may hide origins behind VPNs, cloned websites, or doctored screenshots. A screenshot of a reputable site can be edited in seconds and then passed around as proof. Private messaging apps that use disappearing messages add another layer, because claims can travel widely without leaving a trace that fact-checkers can follow. There are practical signs you can watch for in daily life. If multiple accounts post the exact same phrasing, that's a red flag. If glowing product reviews all read suspiciously similar, they may be paid or fake. When a dramatic claim only shows up in one small corner of the internet and suddenly gets amplified by many accounts at once, ask where the original evidence lives. Simple tools like reverse image search and checking the About page of a website can often reveal copied images or recycled content. It's like checking the label on a mystery jar. A quick look can save you from tasting something sour. Even when professional fact-checkers step in, these networks sometimes adapt by changing platforms or switching to private channels. They can seed doubt intentionally, tossing in tiny uncertainties to make people question clear facts. That tactic turns verification into a treadmill. Answers are chased, but new distractions keep appearing. Still, basic verification methods. Looking for independent confirmation, tracing the original source, and treating suddenly viral claims with skepticism remain effective first steps. A light touch of humor helps. Think of these networks as a flash mob of parrots, all saying the same line until you suspect someone paid for the rehearsal. The reality is less funny when a false claim affects health choices or finances, so spotting the patterns matters. By recognizing coordinated repetition, hidden origins, and purposeful noise, everyday users can cut through much of the deliberate fog and make more reliable judgments about what to trust. Practical verification checklist for beginners. Many conspiracy claims mix a few true facts with a lot of guesswork and missing evidence. That makes it possible to check them using normal tools and careful thinking. Start with curiosity, not panic. It helps to know that ordinary steps, finding the original source, checking other independent reports, and testing simple details, often expose holes in wild claims. Look for the original source first. If a story shows a dramatic screenshot, a short video, or a line of text, track down where it first appeared and who posted it. Originals tell you whether something was edited or taken out of context. Try a reverse image search for photos or screenshots. It often finds earlier copies of the same image. Example: a viral photo claimed to show an explosion in a faraway city. A reverse search revealed the image came from a movie still. That alone doesn't prove anything sinister. It just shows why the claim needs more proof. Check whether multiple, independent sources report the same facts. Independent means they don't all rely on the same anonymous post. Look for reputable outlets or official statements, and work out if those outlets are quoting primary documents or each other. For health claims, read what major health agencies or recognized medical journals say. For company or government actions, check the organization's official page or well-known news organizations that work to verify statements. If only one anonymous account is making the claim, treat it carefully. Ask simple questions about plausibility. Does the claim need hundreds or thousands of people to keep a secret? Would physical evidence exist, and where would it be? If someone says a vaccine makes you magnetic, look at the physical test shown. Magnets stick to lots of things like sweat, bandages, or metal underclothes. Try to recreate the test safely or find others who have. Practical tests and everyday common sense checks are often decisive. Counterintuitive claims demand stronger evidence. Look for red flags in wording and presentation. Emotional language, urgent calls to share now, lack of named sources, or claims that authorities are covering up without showing documents or warning signs. Also watch for cherry picking, using one odd point to ignore a whole pile of contradicting facts. If a claim relies on complex conspiracies with many moving parts but no credible documents, that's a reason to be skeptical. Use simple verification tools and methods. Reverse image search engines, checking domain names and website, about pages, reading the original study or source document rather than headlines, and searching a name or phrase in multiple languages can help. For videos, check for edits, odd cuts, or suspicious audio. For documents, try to confirm whether the file appears elsewhere and whether metadata or letterhead matches known originals. TinEye and Google's reverse image search are handy. Academic claims can be checked on Google Scholar or major medical databases. Consult experts in plain terms. If a claim touches on medicine, engineering, or law, find a neutral specialist, someone who does not have a stake in spreading panic or defending the claim. Ask them to explain in simple language whether the claim makes sense and what evidence would prove it. Many experts enjoy correcting clear errors and can point you to the primary sources you should read. Keep a small checklist with you. Find the original source. Reverse image search pictures. Confirm with 2 independent, reputable sources. Ask whether the claim needs an unlikely number of people to be true. Look for named documents or eyewitnesses, and consult an expert if the claim matters to your life. Test small parts when you can, and don't rush to judgment. A little patience, and these ordinary checks will do more than wild guessing. And yes, they beat a tinfoil hat at revealing what's actually going on. When verification is slow but possible, some claims can't be settled with a quick search. They need time because the proof sits behind locked doors, technical analysis, or slow legal processes. Verification means checking a claim against reliable evidence until independent sources agree. That can involve getting original documents, running tests in a laboratory, tracing a product through a supply chain, or simply waiting for someone with first-hand knowledge to speak up. These steps are often slow, but they're what turn rumor into fact. Journalists and investigators often use more than one route at the same time. They might file a public records request to get official documents while sending samples to an independent lab for testing. A public records request is just a formal ask to see documents that belong to a government agency. Labs perform tests. Independent means a second lab repeats the test to make sure the first result wasn't a fluke. This redundancy is exactly why answers can take weeks or months. Patience is annoying, but it is also practical. Everyday life offers clear examples. If someone claims a new health supplement causes side effects, simple internet searching won't prove much. Scientists need to look at raw trial data, check how the trials were run, and see if another team gets the same result. If a company is accused of hiding factory conditions, verification may require employment records, satellite photos, supplier invoices, and worker interviews, pieces that take time to assemble. In both cases, the initial claim might be loud, yet careful checking is deliberate and slow. Cold cases show how slow verification can still succeed. Old evidence sometimes gets retested with better tools, like DNA methods that are easier and cheaper now than they used to be. Retesting must be handled carefully to avoid contamination, so investigators follow strict steps, which adds time. The payoff is real. What was once an unprovable story can become a solved mystery because the evidence was preserved and later analyzed properly. When an online claim spreads fast, look for signs that verification is in progress. Trusted outlets will say they are waiting for documents or expert comment. Researchers will explain their methods and invite others to check their work. Those are good signs. On the flip side, when answers are promised immediately with no supporting detail, that is a red flag. Quick certainty is not the same as careful proof. Practical habits help you ride out the waiting period without spreading errors. Bookmark or screenshot the original claim so you can track how it changes. Check whether multiple independent sources confirm the same facts. Ask if raw or original data exists, and whether experts who don't stand to gain are backing the finding. If you must comment before verification is complete, use cautious language. A little restraint keeps you from fueling a false story, and it gives slow but solid verification the space it needs to work. Slow verification is not a flaw. It's a feature of responsible truth-finding. It feels frustrating when a claim demands proof that isn't immediate. But the extra hours and careful steps often separate a baseless rumor from a real, verifiable fact. And that, in the long run, saves a lot of embarrassment, and sometimes a lot more. Ethical risks in amateur investigations. Amateur investigations often rely on public posts, photos, and tips gathered online, and that mix creates many ethical pitfalls. Misidentifying someone from a blurry image or an out-of-context post can ruin lives. People have been harassed, ostracized, or even lost their jobs because others incorrectly labeled them as suspects. Doxing, sharing private information like home addresses or phone numbers, is a term worth knowing. It means exposing personal data that puts someone at risk of harassment or harm. Simple actions like reposting a screenshot can have serious consequences, especially when the original context is missing. Legal trouble is another real risk when private citizens take matters into their own hands. Making public accusations without solid proof can amount to defamation, which is a legal claim anyone can face. Interfering with official investigations is also dangerous. Moving objects at a scene, confronting people in person, or contaminating evidence can obstruct police work and even create criminal liability for the amateur investigator. Confronting a person at their home because you think they committed a minor wrongdoing is not heroic. It's risky and not the kind of thing that usually ends well for anyone involved, and that includes bystanders. The emotional fallout reaches both targets and investigators. People wrongly accused often suffer anxiety, depression, and social isolation. Meanwhile, the person who shared accusations can face intense online backlash, doxing in return, and legal stress. Rumors spread fast and retractions do not. Once a sensational post is shared, deleting it later does not erase copies or the memory of it in people's minds. Even good intentions can lead to cruelty when a crowd takes over. Online shaming has a long tail. Practical steps help reduce harm. Verify before you share by checking primary sources and seeking confirmation from reliable outlets. Blur faces and withhold exact addresses when discussing incidents that involve private individuals. When you find something that looks criminal or dangerous, report it to the proper authorities rather than playing judge and jury. Be transparent about uncertainty. Label tips as unconfirmed, correct mistakes quickly, and apologize when you're wrong. Finally, protect vulnerable people. Children, victims of crime, and those with mental health struggles deserve special care and privacy. Think of yourself as a cautious witness, not an armchair mob boss. Manners and restraint are ethical tools as important as curiosity. Cultivating skeptical curiosity. Many claims labeled as conspiracy theories can be evaluated with ordinary tools. Public records, trustworthy news outlets, eyewitness accounts, and simple logical checks. Skeptical curiosity means combining a genuine interest in finding the truth with a disciplined habit of testing claims instead of accepting them because they feel dramatic or fit a story you like. It's about asking clear, practical questions. Who says this? What evidence do they show? How could this be checked? And then following through until you have a better answer or until you run out of reliable information. Start by breaking a claim into parts that can be checked. For example, if someone on social media says the local water tastes odd because of a secret chemical dump, you can first ask for the source, then consult the municipal water quality report online, call the local utility, and look for independent lab tests or news coverage. Often, one of those routes gives a straightforward answer. Simple household checks can help too. If your neighbor insists a street light causes headaches, try spending a few evenings elsewhere and note any difference. Then see whether others report the same thing. Small experiments and direct evidence beat grand-sounding stories every time. Pay attention to how you search and whom you trust. Look for independent corroboration. Two unrelated sources that report the same finding are stronger than many posts quoting the same original claim. Use easy tools like reverse image search to see if a viral photo is old or repurposed, and consult established fact-checking sites when available. Be aware of confirmation bias. Our brains like to keep what we already believe, so deliberately seek evidence that could change your mind. If a friend insists a workplace rumor of secret layoffs is true, check the company's official channels and public job listings before forwarding the panic to everyone in the break room. Cultivate a habit of asking what evidence would disprove the claim. That question forces specificity and makes vague assertions harder to hide behind. Practice framing requests for evidence in a calm way. What would convince you this wasn't happening is kinder than you're wrong. Also, set a simple rule for yourself before sharing a startling claim online. Pause, verify one reliable source, and then decide. This small delay slows the spread of falsehoods and gives your skeptical curiosity a chance to do its job. Humor helps. Think of yourself as a curious cat with a checklist instead of a cat who just knocks everything off the table. Make verification a routine skill by starting small and building up. Try checking the next 3 questionable posts you see and note how you verified each one. Over time, you'll get faster and more confident, and you'll learn which sources are reliable for which kinds of claims. In daily life, this looks like calling city services about a local hazard instead of assuming the worst, asking for receipts rather than rumors about secret deals, and consulting someone with real expertise when a topic goes beyond common sense. The payoff is practical. fewer false alarms, better conversations, and the satisfaction of being the person who asks the right question at the right time, often to the relief of everyone involved. So Myth 26 claims conspiracy theories can't be checked by normal means, but the truth is simpler. Many claims can be tested with everyday tools and simple thinking. Check the timeline, look for original sources, compare independent reports, ask who benefits from the story, and try a quick experiment or search, like checking a photos date or a flight tracker. Think of it like checking a restaurant receipt or looking at timestamps on your phone photos. Basic checks often reveal the answer. If a claim sounds wild, don't panic. Be curious. Ask questions, look for multiple independent sources, and consult real experts when needed. You don't need fancy lab gear or a secret society. Just common sense, a little digging, and maybe your phone camera. No tinfoil hat required. If this helped you, like and subscribe for more practical tools to spot shaky claims, and drop a rumor or viral post in the comments. We'll test one in the next video. We'll walk through checking a viral photo and a health claim, step by step. Thanks for watching. Stay curious, check your sources, and be the calm, skeptical friend in your group chat.